Hello once again, physics fans. Today we're going to do AQA from 2020 paper 1 question 8, and in this question our physicist student is connecting a number of resistors together, in this case in parallel, and using an ohmmeter, which is just a device that measures ohms, i.e. resistance, to work out what the effective resistance of that combination is. So here's some results that they got, and your first question, or your first task, is to calculate the reading of x. Well, you know that the mean is simply the addition of all the readings divided by the number of readings. So your first task then really is to check out, do these two readings look as if either of them are anomalous? Well, you know, it's really hard to tell with two readings, isn't it? And also, well, they appear pretty close anyway, so I think we can say they're okay. So then we know that 15.7 is going to be equal to 15.8 plus 15.3 plus x, all divided by 3. Now I'm going to take that 3 and put it onto the other side like this. 3 times 15.7. 3 times 15.7 is 47.1, and now we'll add up 15.8 and 15.3. 31.1 plus x. So that tells us that x is going to be equal to 47.1, take away 31.1, and that's going to equal x. So x is going to be 16.0. In 8 part 2, the student makes the conclusion that if they take a fourth result, that would increase the precision of the practical, and they get the result 16.2. Why is the student wrong? Well, the student's wrong because this isn't what precision means. If results are precise, they're going to be close together. They're going to show little variation, and 16.2 has increased the range of the values of the results, so they're less precise. So you could write something like this: PREC, precision is when the results show little VAR variation. The new result has increased the range and is therefore less precise. CISE. In 8.3 we can see that the student has carried out practical where they have a number of resistors in parallel, 2, 3, 4, etc., and measured the resistance using that ohmmeter device several times to get a mean for each of the numbers of resistors. And you can see, look, we've got the points coming down in a nice curve. The student makes the rather bold assertion that we have inversely proportional relationship between the two quantities x and y, and we have to check out if they're right. Now, perhaps I'll make a video on what this thing proportional really means, because I find my students very confused about it. For the moment though, inversely proportional is when whatever is on the y-axis, there's the proportional sign, is proportional to 1 over whatever is on the x-axis. This means that to get rid of the proportional sign, we make an equals, and then we write a constant k divided by x. This in turn means that if we rearrange this equation, we get y times x is a constant. And this is our key to answering our question. If they are inversely proportional, whatever value of y we take and the corresponding value of x should multiply up to give us the same constant. So let's check this out. So if we put the y-axis is the mean total resistance. On the x-axis we've got the number of resistors. So let's pick a few points. We'll start off, well, why don't we start off with 2? So we're looking at this first point here, 2 resistors, and that gives us a reading of 24. And we'll work out what the value of k is in a minute. Now we need to, so what I'm doing is picking points off the graph, doing y times x for that point and seeing what value of k I get. And then we'll do that for a few points and see how it works, see if the k is coming out the same. So let's pick point number 3 now. So if x is 3, y is going to be 16. So we put 16 here, and we should do at least 3. So I'm going to jump to point x is 5, which is this one, which comes to here, which is 9.5. So now we have to do because of this expression here, multiply our y's and x's together. So 2 times 24 is 48. 3 times 16 is also 48. I don't know what 5 times 9.5 is. Let's find out. 47.5. Well, it's not 48, but it flipping nearly is. In other words, I think it's a pretty good conclusion here to say that these three readings of the constant have come out the same. And therefore, our student is actually correct in their very strong assertion. It is inversely proportional. Well done, student. 8.4 asks us to explain why adding more resistors in parallel decreases the total resistance. Okay, so here's the original diagram, and I'm going to add a cell across here like that. After all, we need a power supply really, don't we? And then within that diagram, I'm going to add an ammeter like so. Now, if we have three what we know is that the voltage across any of these resistors is going to be identical to whatever the battery is. So if the cell is 3 volts, the voltage across each resistor is 3 volts. So we're going to get the same current flowing through each of these resistors. Now, as far as the cell concerned, the total resistance is just going to be from V equals IR. The total resistance that the cell sees is just going to be R is the voltage of the cell divided by the total current, which is the current that flows down through that ammeter there, that total current. So it's just 3 divided by whatever value that I is. So looking at this little equation, let's bring it up here. Looking at our rearranged version of Ohm's law here, we can see that if we increase this current, this voltage is fixed, it's the voltage of the cell. So if we increase the current here, which is the current coming out of the cell, then that means that R is going to drop. So if we add another resistor into our chain, like a 4th resistor, so suppose we just, for the moment, just whip out the ohmmeter, and add in another resistor, the voltage across this resistor is also going to be 3 volts, just like it is for all the others. And so another lot of current is going to go through that resistor, which means we've increased this current, which means that the resistor is going to fall. Well, how do you say all that? Well, I think I'd do something like this. Adding more resistors in parallel increases the current flowing from the cell. Because we have added in additional routes for current to flow. More current means less resistance because of Ohm's law. Always good to get a law in if you can, and that is that. Yeah, tough question, that one. Again, lots of my students find that very hard. Well, that's the end of question 8. Hope it was useful. Don't forget to subscribe, etc.